Okay, today we're going to go through all of our internal components of our engine, explain what they all do, where they're located, to help with your assignment that has been posted. So we're going to start back down this end here with our pistons. So there's one, a big one. Okay, so there's a couple of pistons here, and we have more components than just a piston on this one here, but our piston is here. Piston head, each space between the rings, it's called a ringlan. Piston skirt is here, and you can see they are a little different from piston to piston, and the top as well. Piston head can be different depending on what we're using it for and how they're designed. And then we also have this one over here that is from a small engine, a Honda, and you can see it as well. It's a little different. You also notice there's a dot here on this one, and on this one here we have an arrow over here, and on this one here we also have a small dot as well. That just tells us that's the front, that part, that piston, that dot or arrow faces the front of the engine. Located in the cylinder of the block, and its job is to move with the crankshaft and allow compression, intake, all of our strokes as it moves. Our skirt is what would touch the cylinder wall, and this one's got a fancy design on it. The black is actually got Teflon coating, and this one has the same type of thing. It's got a bit of a Teflon coating. The skirt's a little shorter. Call it a skirt because it hangs down. And this one here as well, you can see the skirt is a little longer, but no Teflon coating on this one at all. So again, located in the cylinder, its job is to move with the crankshaft to help with the force strokes. We also have a wrist pin. The wrist pin is located here, and here's an actual wrist pin right here out of this same piston. It slides in. This one here, look really close, you can see that's got a ring on there, a little snap ring that holds it in place, and it kind of floats like that. Okay, this is again a small engine, Honda. Wrist pin is basically just a metal pin, hollow, and on this one here, it's got the ring, snap ring on this side and on the back side that holds it from falling out. But on an automotive application like this one here, you can see that if I move it on this one, the connecting rod moves on the pin, but not if I move the pin. If I move the connecting rod, the pin is stationary. Okay. Oh, this one moves a little bit too, I guess. And it's held in by a snap ring there too. You can see it right there. So this guy has snap rings as well. Right there's a snap ring there. So this one here, snap rings in each end. Pin floats in the piston and in the rod. This is the one that I was thinking of, the first part. If I move this one, you can see that the pin actually moves with the connecting rod. And it moves in the piston. So I'm turning the rod, connecting rod, and the pin move together. It's pressed into this connecting rod, so it's really tight in here. That's why we have no snap rings on either side of this style. So the piston pin or wrist pin, its job is basically to hold the piston and the connecting rod together. Okay, allows for the pivoting motion when the crankshaft's moving. And we also have rings, is another one of our components as well. And the rings are located here, and there's 3 of them. 1, 2, 3. These 2 are the compression rings. This one's the oil control ring. So this guy here is to seal the cylinder so that when moving up and down in the cylinder for our strokes, we don't have any leakage. We get a little bit, but we want as little as possible so it allows less leakage past. The control ring here is job is just to control oil. Scrape it out the cylinder walls, so it doesn't get too much up into here where it can possibly get past the rings on top of the cylinder or on top of the piston, and we have burning oil then, consumption of oil. These are different, all three. There's a special tool to remove them, but today I'm just going to show you how to take them off. If I wasn't using them again, I could just roll them off. Sometimes you can't do this because they are quite thick. So that's the upper ring. They are marked, and some of them will have a dot on them or a bevel. And this one has a bevel on it actually, and the bevel is actually right on the inside edge. If you can, really hard to see it, but it's got a slight bevel on it that tells its location. You can kind of see it right here. And then the second ring will also have a marking on it. We can get it off. And again, it's a little bit different than this one. That one's got the dot on it. You can see the dot right there. It would tell its location. Usually with the set of rings, you buy a set of rings, you get them in a box like this. This is the small box because it's from the Honda. And inside the box, you would have your instructions on how they work. And then our last ring is our oil control ring, which is actually 3 pieces to it. And if I roll it, you can see right here where it splits. So this one here comes off like so. There's one part of it, very thin. And then we have another one of those guys right here. There's another one. And then we have our oil wafer type ring, or a corrugated type ring. Those look like cardboard. So it looks like this. So our oil control ring is actually these 3 together, like so. Okay. And then of course our connecting rod here connects to the crankshaft and to the wrist piston. It's got a job of being able to rotate on both ends and support the piston and all the combustion and everything happening on top here. It's got to be pretty strong. And this one, of course, you split it like so, and they come apart to place our bearings in there. And if I'm looking for bearings, I can show you how they look in a second here. So there's the part. You can also put bearings in there. Bearings are like this. So they come in a kit. So these are actual bearings. And you can see there's 2 halves. So this is 1 bearing, 2, 3, 4, and then another set of 4. So it gives me 8 bearings that would fit the crankshaft in that old 327 we have up here in the shop. These bearings are a friction type bearing, and it's just oil basically that lubricates. So the only thing stopping basically the crankshaft from hitting this is that thin layer of oil that we put under pressure in the oil pan. And then we also have bearings here too. These are a little bigger. These are actually for the crankshaft. They're the main bearings. We'll talk about those in a second. They're quite a bit bigger, you can see. And they have slits in them for oil passages through and stuff. So a connecting rod, here's one. Another one. One for a small engine. This one has an oil slinger on it because it doesn't have a pump in it like this one will. If I put them all together, they look like this. That's the whole unit. Okay. Crankshaft. There is a crankshaft out of a R327 that's sitting over in the over here. So we'll wander over here. 327 is right there. That's the block for it. So these components come out of that. So this crankshaft, you can see, is quite a bit larger than our this guy. So this one here is basically our crankshaft from our small engine, single cylinder. If I held up the piston or the connecting rod, I can see that only one connecting rod will actually fit in there. Let's open it, kind of like this right here. Okay, single cylinder, and as it spins, the piston will move down in the cylinder, and then as it comes around, it will allow it to go up. So it just basically pulls it down, allows it to go up. Okay. So on our crankshafts, you can see the both of them there, are, if you notice that the crankshaft, this is a pretty big unit and a lot of weight on it because it's got to counter the pistons. The pistons are moving up and down, so it's got to counter that weight. So we have here and here and here and here and here are all the center. So if I ran a line through the center of the crank all the way to this, these would all be in line with each other. This one looks like it is, but it's actually toward us more because it's one of the crankshaft throws. These are called main bearings. So these big bearings here that I showed you, that's where they would go, and they're supported by the block inside the block. So this whole shaft sits inside the block, and it's held in there and bolted in, and these bearings are part of it. So as it spins this way, or whichever direction it would turn, clockwise or counterclockwise, and it spins on those bearings. Okay, all of these further ones that actually are off in a bit of a, you can see this one here, it's way up. Okay, this one is as well, but we just can't see it as well because it comes this way toward us and out. And this one here, you can kind of see it as well. It goes down and up. So our connecting rods bolt to these journals. We call them journals. So these are main bearing journals, and these are connecting rod journals, or con rod journals, or con journals, whatever you want to call them. And the way they work, if you see here's our piston. If you look though, if I put that on there, there's a lot of space there. We could actually fit another one in there, couldn't we? Right? So we have two pistons on one connecting rod. Okay, I'll move this down a little bit so you can see better. There's your other piston. So those two pistons would be on one connecting rod. So for every single connecting rod in this particular engine, we have two pistons, two connecting rods, two pistons, which would make this two go here, two go here, two go here, and two go here. So 2, 4, 6, 8. This is an 8-cylinder. We have 8 pistons attached to it. Now, if we have two pistons on one connecting rod, then that would mean we have two pistons that are both going to be at top dead center at the same time. But they're not doing the exact same thing. If one piston is on the intake stroke at top dead center, the other piston will also be at top dead center, but it'll be starting the power stroke. So at any given time in a V8, you could have, you're never going to have a power stroke, two pistons at the exact same time. They stagger them all so that we get a better running engine. Okay, so what's the crankshaft do? It's housed in the block. Its job is to turn, spin, and move those pistons up and down the cylinders. And one of the things we talked about class today was these gears, this gear here and this gear here, on the other end right here, and they were our timing gears. So on this gear, we'd have a timing chain, or a belt, or another gear that would connect this part to the valve train. So where our valves and our camshafts, so it'd be connected to the camshaft via belt or chain. Likewise with this one here, if you guys remember, we talked about this one before. And if I grab my camshaft, here's my camshaft, and they were on together like this, and they spun. And if I look at the size difference, if we remember, we had two timing marks on these things, and this one is right, where did it go? I cannot see it. It's right there. It's hard to see. You can see it right there. So that mark and this mark go together, and so as they turn, the camshaft gear is twice the size of the crankshaft gear, so the camshaft moves half the speed. This will turn 2 revolutions to 1 of this one. Okay, and if I go back over here again, I can see on this one I have a set of timing. There's 2 cams in that engine. Crankshaft's at the very bottom down here. There's my gear, my pulley for the front of it. I can see here, and here's my timing chain, goes all the way around to both those camshafts. We got 1 cam here, 1 cam here. So 1 cam is going to be intake, 1 cam will be exhaust, and those will spin half the speed as our crankshaft. Okay. The other thing our crankshaft does is it's where we measure RPM. So remember, RPM is revolutions per minute. So we're basically running this thing as it spins. We're basically, as every time it spins, we count it spins. And typically on today's vehicles, we have a sensor that will count teeth. Not these teeth in particular. This is not a crankshaft speed like an RPM sensor ring. This is for the timing, but we have another one somewhere else on this crankshaft that would basically count the teeth as they went by, and it could calculate RPM. Okay, camshaft. Here's our camshaft right here. Again, that's out of our 327, and it's got quite a few lobes. If you look at this guy right here, it only has 2 lobes, one here and one here, and then the gear itself. On this one here, you can see we have multiple lobes. So we have, if I look at this one, and this one, that one, that one, and that one, those are all bearings. So this camshaft spins on those bearings. It's the same type of bearing, okay, as the main bearings and the connecting rod bearings are a friction type bearing. And this unit goes actually into, if I look here, I can see that hole right there. It goes in that hole and goes all the way to the back. You can see all the little holes on top of the block. That's where my lifters were going to go. That pushes up and down for my valves. On this one though, my camshafts are overhead. So this is a 4-cylinder engine, inline 4, 2 camshafts. That's a dual overhead cam system, where that one there is going to be single cam in block. Quite a bit older system. If I look at this one again, I know that each one of these lobes has a job. One lobe will open intake valve, one lobe will open exhaust valve, and no different than this one as well. But this one here, you can see I've got 1, 2, 3, 4, and then 1, 2, 3, 4, and then 4, and then 4. Out of the 16 lobes, and they're egg-shaped. I can see it like this. See, they're kind of egg-shaped, and then that one there too. Got a point on it, so the valve is lifted by this part. So I have, on this system, I'd have 2 intake and 2 exhaust. So for each cylinder, I'd have 2 that would open, 1 would open intake, exhaust, all the way through. And it would cover 8 cylinders in this one, right? If I roll over to here, I've got all my valve chain components. Depending on the type of system I've got, I could have push rods like this one right here. So basically what we're looking at is we have lifters, and on an engine, this style engine that we'll have before, this is what there's 4 in this box. This is a lifter, and it sits inside the block, and the holes I was telling you about earlier, over here, the holes on top of the engine up here, they sit down inside them. Crank camshafts in there, and the cam pushes up on these, which in turn pushes on these push rods, because they sit in like so, like that. And then on top of the other end over here, I'm going to have a rocker arm like so, and it rocks, and this side of this thing here pushes down on a valve, and it opens and closes the valves in the cylinder head. So these are all located in the cylinder head. They all have specific jobs. One, of course, intake and exhaust valve. You can see here, I have one. This is a valve out of automotive engine. This is out of a small engine like our Honda motors. This valve is quite bigger than this valve, and likewise with these two, this valve is bigger than that valve. So these are intake, these are exhaust. Here's the rocker arms for our engine, like our automotive engine, and these rocker arms right here are out of our small engine, like our small Honda motors. These springs are automotive springs as well, so they're quite a bit heavier. These are springs out of our small Honda motor. Now these ones here, you can see I really can't squeeze them really because they're really stiff, but these ones, they're pretty easy to push. I can take my valves out by hand on a small engine like our Hondas, but on a car, these type of valves, they're too strong. Now this isn't the only system, because if I look at the other system on this motor over here, that one right there, it's totally a different type of system where we don't have a lot of the components we're seeing down here. So a lot of the components that are down here would not be in that engine. Similar components. It still has valves, still has lifters. Now the lifters on my small engine are quite a bit different than these ones. We call them tappets as well. Okay, these are hydraulic. They get oil filled, so they take up. There's a spring inside them. It takes up the clearance in the valve hold train, where this one we have to set by hand. So, but you can see the same idea on the bottom. Okay. Other thing we have, spark plugs. Okay, I'm gonna go back for a second to over here. Camshaft can be located in a couple different places. In the block, in the cylinder head, typically today cylinder head, and it can be either a dual overhead cam version or a single overhead cam version. These components here are housed in the cylinder head, most of them. The lifters on this style engine over our old 327, the V8, these are in the block. These are in the block. These would be in the cylinder head. All of this stuff here, including the valves. Okay, our spark plugs. Now these is a typical spark plug out of like a small engine, and this one here, these are a little bigger. These are brand spanking new, a little bigger, and they are basically out of these are out of a car. I'm not sure which vehicle we ordered them for, but they're a little bigger. And again, spark plug's job is to fire the fuel and air mixture by using a coil. And we'll get to a coil in a minute. So the coil creates power, and it goes through this, and the spark gets to the end and jumps that gap right there. That little gap, it jumps when it jumps the gap. It creates spark enough to ignite the fuel and air mixture that's in our cylinder and create a big boom. So that's our spark plug. And again, you can see they're very similar. Just one's bigger than the other. So we get different types of plug. You can't just jam any plug in a vehicle, because there's a lot of times it could be longer plugs, shorter plugs. Depending on what the application, we have to change the plugs out. These are located in the cylinder head typically. And again, we have to have an external item, our coil, to create the power to run through this thing to actually create the spark. All right. If I go over here now to my cylinder head, I have two here. I have this one here, which is my small engine one again, and then a larger one off there's 4 chambers here. So cylinder head is typically on top of the engine. It's bolted to the block. So there's 2 pieces I can see on this engine right here. The cylinder head is here, and you can see where it's a definite line here, where it's got the aluminum cylinder head and then a block underneath it. So this right here is our cylinder head. This is our engine block down here, and on the one over here, you can see this part right here, the flat part, my cylinder head, this one here, would bolt to that component there. Cylinder head's job is it houses the combustion chambers. Okay, so my spark plug goes here. I can see I have 2 valves here. I have an intake valve and I have an exhaust valve, each cylinder. and a spot for a spark plug. And this right here, the small area, is called a combustion chamber. And this has a gasket between this part and the block. If I looked at it this way, I'd notice that I have my ports. So this will be my intake. So every one of these is my intake. So I have enough. These are my water jackets. So coolant runs through this, through the cylinder head and out the other end. And I have 4 of these. So these are all intake. So the intake, so for each cylinder, there's 4 cylinders on this side. This is my intake for my 4 cylinders. And this is for coolant here. And if I look here, I'll also notice I have a bunch of holes for bolts, but also ports for cooling as well. Okay, I have some cooling ports that coolant runs through the cylinder head, through the cylinder block, and it's got matching holes in the cylinder block over there for coolant to run through. And if I flip it over here again one more time, I would see on the other side of this thing, I have 4 more ports. There's the spark plug holes, and these are exhaust. So I have exhaust manifold here. So intake on the other side comes in, we burn it. On the exhaust stroke, it comes out of these 4 ports on my manifold to be attached to it. I can also see in here too that I have my valve springs are all here. So this is the top of my valves, and my rocker arms bolt to here. So if I had a rocker arm, it would actually bolt to here, and it would actually move. My rocker arm would come through here, my push rod would come through here, and I'd bolt this down, and it presses against the valve. So if it tips like this, it opens and closes the valves. So again, located on top of the engine. It can be made of cast iron, it can be made of aluminum. It wholly depends on the design. Again, this one's made of steel, cast, and this one right here is made of aluminum. Okay, and then I could also see here that I have a small one made of aluminum from our Honda motor, single cylinder. Again, spark plug hole. My valves would go here. I can flip it over. There's my 2 valve ports. Spark plug here again. And I have components. My push rods actually go through this. And this is air cooled, so there's no ports for cooling. That's what these fins are for, to keep it cool. And I can see that I have a port here and also a port here. So if I want to know what is what, big hole for the bigger valve, intake goes through. You can see my finger in there, so air comes through. And then of course on the other side here I've got my exhaust, and exhaust leaves through here out the muffler. Okay, cylinder head, this one's made of aluminum, typically top of the motor. Okay, I got a couple things here I want to show you as well while I'm in here. This one here is for our 327, and what's in this guy is our timing chain and gears. So this is what a set would look like. This part right here goes onto the crankshaft, and this goes on the cam. You can see it's got holes in it, and another little spot here that's actually so it's in the right position on the camshaft. And this is my chain. So this is a chain driven style. And if I go like so, you can see that it would look like this on the engine once I had it in place. So that's how it would look if it was bolted all together. It's getting jammed up there. Hold on. There. Okay, so that's what it looked like. It's a pretty hefty chain. Okay, so that's what it would look like on our older motor. This right here is our oil pump. So this is what a pump would look like if you were putting a new one in. And it bolts to the bottom of the block. It looks like so. And it's missing a couple of pieces. This is what turns it, spins it. It's driven by the camshaft. Okay, it spins it off the camshaft. This bolts to the block. And then the bottom part, you can see I have a hole here. It's got a tube that comes out of it and dips down inside the oil. So when this thing spins, it sucks up the oil into the pump, and then it goes up through here and fills the block up. and then pushes the oil up to the top of the engine. Inside here, I don't think you can see it. Let's see if I can turn the light on. No, we can't see inside there well enough. It's gears inside there. That actually is the pump. So it spins and it pulls oil. Okay. The other thing on our list, valve covers. A couple of old school valve covers on this one here. This one here is off of our small engine Honda motor. This one here is off of our Chevy 350. A little old, right? But it's got a gasket on it. Sits on top of the, there's our cylinder head again. So basically it sits on top of the cylinder head like so. Keeps the oil in, so it doesn't leak everywhere. And we call it a tappet cover or a valve cover, whichever way you want to call it. It's both the same idea. But that's what it does. Okay. On this engine over here, you can see that it's a little bit different because it, again, is a dual overhead cam system. So it's quite a bit bigger. I'll come around this way. It's got some pieces missing on the top here, but typically this whole thing right here, you can see it, it's all valve cover. So it covers my, I can see my cam here. In there, I can kind of see the other cam way down in there too. So I have a camshaft, I can see the lobes, right? Here's one lobe, here's another lobe. If I was to pull this off, I'd see all the full camshafts. This is the cover as well. My spark plugs are in here, in this style, and my valve train is really compact, not like the other one where I have all the push rods. I've basically got our lobe is here, and right below it's going to be our, if I can see it or not, our valves right down there. You can kind of see them hanging out down there. Okay. Okay. Cylinder block. Of course, that's our cylinder block right there. And likewise, this guy here, the bottom half of that guy's our cylinder block. And if we're looking at a Honda motor, that guy's our cylinder block. That one's made out of cast, as is that one. That one's made out of aluminum. Again, lighter duty. Can be aluminum. There is blocks out there made of aluminum, but the cylinders are never aluminum. They're too soft. They'll put steel inserts inside. So for example, here you'd have a steel insert in here. Aluminum can't handle all the pressures and wear. Okay, so this would be a steel insert in an aluminum housing. Okay, so our cylinders here, and our block, the rest of it's our block. Okay, likewise on that one over here, you can see this, that's what we call a block. Each hole, big ones, are our cylinders. So basically our cylinder's job is to house a piston and help create a seal, and it gets as part of the block. So its location is part of the block. We have a couple ignition coils here, a couple different styles. This one here is called a coil on plug, or sorry, not coil on plug, coil pack, where you got multiples. This is a coil on plug, and this one here is a coil of a small motor, small engine. Again, they're located, could be all over the place. This is inside, actually inside the engine. This one here is on top of the engine. This is usually in the plug hole right above the spark plug. And then we've got a couple air filters here. Air filters located in the housing. Again, they can be located in different places. And this is our small engine air filter as well. So it's a little bit different. This one's actually two-piece. Comes apart. You clean the outer one, clean the inner one. This one here, once it's dirty, we basically just replace it. Okay, pleated paper. This is one style of many. Pleated paper. Located in the housing. Again, that could be depending on where you want to put it. This is our flywheel. Basically, that one right there is a flywheel for an automatic transmission. And this one right here is a flywheel for a manual transmission. This one's quite light. And this one here is quite a bit thicker and heavier, because we also have a clutch disc that goes on there and a pressure plate that goes on top of that. Flywheel is attached to the back side of the engine and connected to the crankshaft. You can see the holes here. They're all, this would bolt to the crankshaft, and likewise with this one right here, it would bolt to to the crankshaft as well. These holes right here. And then of course we have this in right here. This one is a flywheel or a small Honda motor. And the difference in it is it's got a big fan, so it actually helps cool the engine, this thing. It moves air, and it's got a magnet on it. And basically on this system, we have our coil. It's actually bolted really close. See, not magnetic here, but right here, magnetic. Not magnetic, just falls off. The reason we do that is as this passes by, we have a really small gap in here. As it passes by, it induces magnetic field, induces a bit of a voltage into the coil, and then that gives us our spark. So this is what gives us our spark. Okay, again, located in the crankshaft, and it's located right close to the flywheel. But the other two coils we talked about, these two, this is on top of the engine typically, and again, this one sits right. If I looked at this engine over there, it would go right inside the holes on top of the engine, right on top of the plug. Okay, that is our parts. I don't know if I answered every question and locations and what they all do, but that's part of the assignment, so you guys can look it up. Anyway, there you go.